Greetings and welcome, friends. We are continuing our look at factoring quadratics, all right, where your leading coefficient is not 1. And today we're going to talk about what do you do when a times c is negative. And the only difference, and I use that word as a pun, is if they multiply to be negative, instead of finding the factors of AC that add to B, I'm going to find the ones that subtract to B. And that's it. That's it. So let's jump in and do some problems, and we'll conveniently be rehearsing yesterday's skills simultaneously because these are only slightly different, and so we'll get more familiarity as our brains recognize patterns and we get the practice we need. So here we go. All right, so factor. Bam. This has a leading coefficient that is not 1. So I can't just do the regular old find the factors of C. I need to find the factors of AC. So over here, I'm going to figure out what is A times C. Well, 2 times negative 7 is negative 14. Oh, negative. Negative. All right, here we go. So find the factors of 14. So that's like 1 and 14. That's like 2 and 7. All right. And of those factors, I want the ones that subtract to be 5, ignoring the signs right now. So 1 and 14 have a difference of 13. 2 and 7 have a difference of, cinco. C, mis amigos, C. All right, so that's the only difference between this and yesterday's process, right? So I found the factors of AC that subtracted to B, like so. And then the rest of it's identical. Split the B term into two like terms whose coefficients are the factors you just found. So let's do that. Split that B term. Break it up. Here we go. So I'm going to have 2x squared still hanging out. And 5x, negative 5x, is going to split into a 2x and a 7x. And then minus 7 is still hanging out. Now I've got to figure out the signs for these two like terms, and they're like terms because they have the same variable and the same exponent, right, as the original B term. And let's see, for signs, well, they've got to multiply to be negative. All right, so that means their signs are different. It's either going to be plus minus or minus plus. And they've got to add to be negative, so that means the more influential of them is negative. The more influential one here is 7. So that's a negative 7 and a positive 2. All right, so that was the step 3 one. Now, step 4 is called factor by grouping, and that's how we can factor some 4-termed expressions. Oh, no, well, let's see. Let's do this together here. So I'm going to find the GCF of the first 2 terms. And let's see, between these first 2 terms, 2 and 2, what could I steal from those? I could steal a 2. And between x squared and x, how many x's can I steal? Just one of them, just an x to the first. All right, and between, these, I could steal a 7. Can I steal any x's? Nah, because the last term doesn't have an x to give me. Now, because this minus sign is here, I have to take out that minus sign. That minus sign is coming with me. Otherwise, in my next step, my parentheses won't match, which we talked about how they have to match. So anytime this is a negative, you've got to take that negative with you. All right? So 2x outside a set of parentheses, and then minus 7 outside a set of parentheses. Now let's see. I'm going to, for my internet friends, I'm going to take a break here, and I'm going to let my students try to figure out what goes in those parentheses. So I'm going to walk around. And in the meantime, you guys on the internet can just like hum some music to yourselves. second set. All right, so internet friends, I'm back. So 2x times blank is 2x squared. Well, this one's already got the 2, so I don't need another one of those. And x times x would give me x squared. And then 2x times blank is 2x. We decided that was plus 1. We're hoping we'll have the same thing over here. Let's find out. Negative 7 times what would be negative 7x? Yeah, it looks like x, and that's got the minus sign. This one's got to be positive. Yeah. And negative 7 times what is negative 7? Positive 1. The parentheses match. So my answer is going to be the one of those matching parentheses, and then in the other set, it's going to be the GCFs, the 2x minus 7. Okay? So it's the same idea. It's just this time we found the factors of AC that subtracted to B. Here, let me do example 4. Example 4. Yeah, that's worth doing. Yeah, so you might have to flip through your packet a little bit to find it. Example 4, do one more. We might actually do even one more after this. I'm unsure. I want an equal one. Yeah, maybe we'll talk about giraffes. Okay. So one of the things to be aware of here is that this has a minus sign in the beginning, in the leading term. The way I'm going to deal with that when I see that happen, I don't like having a minus sign at the beginning. So I'm just going to steal a negative 1, right? 4, 8, and 5, they don't have anything in common, but I can take their minus sign. So I'm going to write this as negative 1, parentheses, and it's just going to opposite all of these. So it's going to become positive 4x squared, positive 8x, and the opposite of positive 5 is negative 5. All right, so anytime your leading coefficient is negative, just steal a negative from everybody to give it a positive leading coefficient. And now on the inside of parentheses, I'm going to try to factor this further. And in that case, I could find the factors of AC. And 4 times negative 5 is what now? 4 times negative 20. Agreed. And hey, AC is negative. So I'm going to find the factors of 20 that subtract to be which of these numbers? 8. Yeah, the B terms coefficient, right? So factors of 20 are 1 and 20, 2 and 10, 4 and 5. And of those numbers, I'm finding the ones that subtract to be the B. All right, so 1 and 20 have a difference of 19, 2 and 10 have a difference of 8, 4 and 5 have a difference of 1. Looks like I found my winner. If I don't ever find the factors, that means that it's not further factorable, okay? Just so you're aware, if it just doesn't work out. All right, so split this B term into 2 like terms. Yes. All right. This negative 1 is going to be way on the outside here, still. Okay, so negative 1, way on the outside. I'll have 4x squared. 8x is going to be broken into a 2x and a 10x, and then minus 5 still hanging out. Close parentheses, right? Because that minus 1 is just hanging out, all right? Let's see, as far as the signs for the 2 and the 10, they've got to multiply to be negative, so they're different, right? They're either going to be plus, minus, or minus plus, and they have to add to be the positive 8. So the more influential one must have been the positive. Now, we're going to have to be careful with all our parentheses here, so watch what I do. So step 4, factor by grouping, take the GCF of the first 2 terms and the last 2 terms. All right, whoop. Between the first 2 terms, 4 and 2, what could I steal that both of those can afford? 4 and 2, what goes into both 4 and 2? 2. And between x squared and x, I can steal an x. And between 10 and negative 5, I could steal a 5. This is positive, so I'll keep this positive. And this one has an x, but that one doesn't, so I can't steal any x's. Now, this is where I've got to be careful. This negative 1, I'm going to put -1 on the outside of square brackets. All right. And now I'm going to have this 2x on the outside of a set of parentheses with space for 2 terms. And I'm going to write the +5 on the outside of a set of parentheses with space for 2 terms. So with like all of these, nested parentheses inside of parentheses, I'm using just these square brackets to try to indicate like, all right, these ones go together and then the little parentheses stay together. All right, that's what I'm trying to do. Because I don't want to forget about that -1 that I took out all the way back at the beginning. All right, 2 times what is 4? 2 times what is 4? 2 times 2 is 4. And x times what is x squared? X. And 2x times what would be a -2x? -1, yeah. And let's try the same thing over here. 5 times what is 10x? Well, that's 2x. And 5 times what is -5? That's a -1. And hey, my parentheses matched. So my solution is -1 on the outside times a set of I guess 2 sets of parentheses. I'll have 2x minus 1 in one of those sets, and then the GCFs in the other, the 2x plus 5. All right, and that is my answer. So the only weird thing about this is that there was a minus sign kind of on the outside of the whole thing. A little bit weird, but it still works. You just got to remember that all the way at the end. Okay, let me show you guys example 5, and I'm going to try to wrap this up. With example 5, we're going to do the factoring thing, but it's going to be equal to 0 again. Remember what happens when it equals 0? I'm going to use zero product property. All right, so that's what we're going to do. So here we go. The length of a rectangular game reserve is 1 mile longer than twice its width. What? Okay, so let's draw this rectangle. All right, so it's got a width, and then the length is 1 mile longer, so that means I'm adding 1 to twice the width. So what is 1 being added to? How would I describe twice the width using algebra? Yeah, twice. 2 times w. All right. So 2w plus 1 is the way I could describe the length. And the width we'll just call w. And it says the area is 55 square miles. 55 is the area. What is the width of the reserve? Now, this would require us to know a formula regarding the area of a rectangle, and area of a rectangle is length times width, right? Agreed? Yes, yes. So let's write that out with all of our facts. So I'm going to have, I'm going to write width times length, which is fine. W times 2w plus 1 is going to equal 55. And my goal is to solve for w. So track with me here. This is going to get weird, but that's going to be okay. So the first thing I'm going to do is distribute. Because even though this is factored over here, it's not equal to 0, which makes me sad. Right? I can't use zero product property. And there's no such thing as the 55 product property. So sad. So let's see, let's distribute. W times 2w is 2w squared. W times 1 is plus w, and that equals 55. Now, to solve equations, I want to set this equal to 0. So what do you guys think? How could I do that? How could I get this to be 0? I agree. Yeah, good recovery. Subtract 55 from both sides, and I'm going to get the 2w squared plus dub minus 55 equals 0. Now, what's nice about that is it's equal to 0, and I'm hoping I can factor this, set the factors equal to 0, and solve them. That's my goal. That's where I'm going here. In order to factor that, I realize, hey, the leading coefficient is not 1. So I'm going to have to multiply AC. So let's do that. So A times C 2 times negative 55 is negative 110. Yikes. All right, we're going to have a longer list of factors here. Let's see how I do. So the factors of 110 are 1 and 110. Let's see, 2 goes into that. Looks like 55 times. 3, no. 5, ooh. Now 5 goes into 55 11 times, and 11 times 2 is 22. 6 won't work because 3 didn't. 7 doesn't work. 8, no. 9, no. I think 10 doesn't. Wait. 10, yeah. 10 went into the original. 10 times what? Did you have an answer? Oh, okay. Let's see. How many times does 10 go into this, do you guys think? 11, yeah. And then 11, I'd be like, oh, no, I already got 11, so I'm good. All right, so there's my list. And of these factors, because this is negative, what do I want these factors to do? I'm looking for the pair of factors that does what? I want them to subtract to be the B term, which is a positive 1. All right, so let's see. So this has a difference of 109. This has a difference of 53. This has a difference of 17. And this has a difference of 1. Hoorayness. So let's split that B term into 2 like terms, friends. Guys, we're on the road. On a safari. Gonna find the width of the pen for giraffes. Here we go. So 2w squared hanging out. I'm going to break this into a 10 dubs. Let me make that 0 better. 10 dubs and 11 dubs minus 55 still hanging out equals 0. Don't forget it. Still equal to 0. This is an equation, not just an expression. Okay. Now, what about the signs of this 10 and 11? Now, they've got to multiply to be negative. That means it's either plus minus or minus plus. Their signs will be different. But they have to add to be positive. So what are your guys' thoughts? Someone help me out. Who's going to be the positive one? 10 or 11? Who's going to be positive, 10 or 11? The 11, the more influential one because the answer is positive, so the more influential one must be positive. I agree. All right, guys, we're doing this. Factor by grouping now. Let's see. Yoink, yoink. I can steal a 2w. For sake of time, I'm just going to go a little quicker through this. Between these, I could steal a positive 11. I'll have 2w times a binomial plus 11 times a binomial equals 0. Lots of stuff going on in this problem, right? 2w times w is 2w squared, and 2w times negative 5 is going to be negative 10w. Let's see, 11 times what is 11w? What do you guys think? 11 times what is 11w? Yeah, w. And 11 times what is negative 55? It's got to be negative 5. And hey, our parentheses match. So I've got w minus 5 in one set of parentheses and the GCFs in the other. So 2w plus 11. All right. Whew, this problem is still not done. These giraffes still don't know how wide their game range is, their game reserve. I've got 2 things that multiply to be 0. What do you think I can do? 2 things multiply to be 0. Therefore, by the 0 product property, either or. I like it. All right, let's solve these. Yeah. All right, yeah, keep going. You're on a roll. I like it. He's on fire. 2w is equal to negative 11. So, yeah, divide by 2. Yep, I'm trying to... Negative 11 halves, which is negative 5.5. Now, I get 2 answers algebraically, but what does w represent? the width of this game reserve, I don't know if you guys are dealing with antimatter giraffes, but I think a negative width would be a weird dimension for a fence to build. So I'm thinking that the width must be 5. No, yeah, it doesn't work. So it's 5 miles wide is our answer. Wow, long problem there. I don't know if you guys even had enough space to do it all. Sorry about that. Thanks for watching, Internet friends. Have a great day. Bye-bye.